Hey everybody, welcome back. If you check out the new way I'm trying to do some notes today, I'll kind of keep it quick because I'm just learning this thing called Notability right here, and I'll see if it works okay. I'm doing a little thing right in the name of the program, and I just have a few pictures to show you to do a quick recap from this week. One, we've been learning a little bit about different types of rock, and you might recognize this mountain right here. This is Montara Mountain. And if you were on the top of Montara Mountain, right about there, you'd be almost, but not quite, at 2,000 feet above sea level. Now, pointing out Montara Mountain, this right here, the mountain in the foreground, not Montara Mountain. This right here is some sedimentary rock. We'll talk about that in just a second. But this dark mountain that you see marks the south end of our city here. This right here is a big piece of igneous rock. It's been moving north on the San Andreas Fault for about the last 20, 25 million years. Go back 20, 25 million years, it used to be down in Los Angeles. And you're looking at igneous rock, which does not contain fossils. However, the rock here, if I can draw that, learning my new program here, the rock here does contain fossils, and we'll talk about that in just a second. So let me scroll up just a little bit and show you what I'm talking about. We talked a little bit about this type of rock. Now, this is an artist's rendition of something you've probably seen before. This is Half Dome in Yosemite. Now, we watched a tiny bit of the gentleman Alex Honnold climbing El Capitan, one of the other giant rock faces in Yosemite. And Yosemite, of course, is really known for these fabulous, fabulous giant rock walls. If you're talking climbing this, for example, in the case of El Capitan, you're talking a 3,000 foot vertical face of granite. This right here is a little bit less than 3,000 feet, but the point is this is made of granite, and this is an igneous rock. This is why artists take some time up there, because it's absolutely stunningly beautiful when you check it out in person. And one other little thing to note, it goes back to our notes that we had. If this is the ground level right here, going back, in the neighborhood of, say, 200 million years, all that granite that makes the Sierras was a big lump underground. It was cooled off igneous rock underground. When you're standing on the Sierras now, you're really standing sort of like on the tip of a little iceberg. Most of that granite is still underground, and you're seeing the little tiny piece that stands up at the top. That's where you are right here when you're up there skiing, climbing, doing whatever it is you do. But the granite that's up there, again, all igneous rock, it's cooled off hot lava. And if we go down just a little bit more, why are we studying the rock cycle? We want to find fossils. One of the biggest things that we talk about in this class, of course, is evolution and the change of life over time. Check out this recently taken picture right here. One more picture from the Sierra Nevada. Here on top, in other words, in the distance right here, you've got the granite peaks. This particular picture was taken looking roughly south. And what you're looking at here would be, or I put the little arrow, would be roughly Squaw Valley and North Star, if you know those ski areas up there, the Lake Tahoe Basin. But check out this. Let's try a different color if I can right here. I'll try something like green just to kind of make it stand out a little bit differently. This rock right here is what we call metamorphic rock. And I'm going to draw one more little picture down below. Again, getting used to the program, so bear with me. It's the first time I've used it. But as you look at that hot lava, well, technically magma that's underground, it cooled off to form granite, but you got to remember, this right here is very, very hot. Any rock, let's change color one last time, that it came in contact with, say the rock that was right next to it, might have been fossil-bearing rock, but it got cooked, it got baked. This became metamorphic rock. So metamorphic, writing again, this is in our notes from this week. And the metamorphic rock is what you see right there that I've outlined in the green. This rock right here, it got baked by the granite. As the granite pushed its way up, as the granite was uplifted because of moving continents, you've got metamorphic rock that was created from the hot rock here that then got in close contact with probably some old sedimentary rock, what we call the native rock. Check this out, another local tie-in you might remember. This, of course, was a carnivore, which, of course, we know is carnivore from those teeth right there. We know it was a carnivore that was found right here on our campus here at good old IBL, most likely fox that was probably the victim of a coyote that we've seen around here. And that again goes into the food web that we see on campus. But what we're interested in when we're studying rocks is looking at something like this that has been preserved in the fossil record. Now, this was out there, maybe about 2 weeks, and you'll notice that there's not much left of it. There was just a little bit of the vertebrae. Of course, the skull was left, one of the last, largest, hardest parts. But the point is, we want to find these so we can talk about change in life over time, natural selection and evolution. However, we happen to live in a spectacular spot right here, and we are lucky about one thing. You'll notice this right here, you might recognize the area. This is Lindemar Beach. And as you check out the area around Lindemar Beach, this is the spot where if things are just right, you can possibly get fossils created because you've got sedimentary rock. Remember, sedimentary rock only lays down in water. That is the basis for the next slide that you're going to see. I'm just going to scroll up and show you two more quick things. The next part you're going to see is from a nice little walk that you can do right here in town. Rarely do you see sedimentary rock so perfectly laid out. So, okay, I'll change colors yet one more time, and I'll put it in red this time. This right here is on the old Devil's Slide Trail. Each one of these layers that you see that I'm marking with my pen right here, you can then trace to Sandpaper Rock. So I'm going to write this right here, see it for yourself. Devil's Slide Trail. A gorgeous trail. It used to be part of the old Highway 1. Now it's a hiking trail that you can go check out. You see right here, it's actually a little mini alluvial fan, which is where you get like the tailings that kind of wash off from up above where it's worn off. But the most important thing we care about is these layers right here. Layer by layer by layer. You can match up these, say with one more last picture here. These right here. This is taken just a little bit up the road from where that last picture was taken. And again, right here you can see my car keys for scale. And when you're looking at these layers right here, again, that I'm marking with my pen, incidentally, these around the Devil's Slide Trail are in the neighborhood of 25, 30 million years old. You're looking at something that is younger than the dinosaurs, but much older than human beings. And you can find some marine fossils in here. If you look under using a microscope, you take this rock, you crush it up with a light acid, and you look under a microscope, you can find some fossils in there. What we care about, of course, in this class, going into the next unit, are looking for fossils. And remember, you only find fossils in sedimentary rock. Igneous rock too hot, and metamorphic rock also get baked by the igneous rock usually, or by pressure, and it's also too hot. So we'll get back into this when we have our notes tomorrow, which is Thursday, and then also on Friday. But wanted to show you a couple local pictures and use a new program called Notability. First time through is probably a little clunky, but hey, I wanted to get something out there and get used to using a program that I downloaded from the internet. Take care, and I'll see you guys soon. Bye-bye.